lesson is going to be talking about the special systems of equations that we have to be able to solve. These include your coin problems, current problems, and interest problems. Our first example is one that is a coin problem, okay? So this is number 1. It says Bob has 30 coins, so he has a total of 30, and they consist of quarters and dimes. Quarters are worth 25 cents, which we write as 0.25, and dimes are worth 10 cents, which is written as 0.10. The coin's combined value is $3.75. Find out how many are quarters and how many are dimes. So we need to label our variables. So x is going to be equal to my quarters for here. Y is going to be equal to my dimes, and that's the number of dimes you have. Okay, so from here we're going to write our equations. So the first equation I'm going to write is going to be in reference to the total of 30 coins. X and Y represent my number of coins of each type, so I'm going to say x plus y will give me a total of 30. So x plus y equals 30. And then I have a total of $3.75, or Bob has a total of $3.75. And so we need to add up what we have for each amount. So I have 0.25 times x, so 25 cents times my number of quarters, plus 10 cents, or 0.10 times my number of dimes. Okay, from here we can solve for how many coins we have by setting up our matrices. So I have x is equal to, and y is equal to. Okay, remember your bottom matrix, or your C matrix when we actually plug it in, is going to be the same. So I have 1 with 0.25. Okay, so it's my first 4 numbers, and then 1 with 0.10. And then my Y matrix on the bottom is the same, 1 with 0.25 and 1 with 0.10. The top of my matrix for X is going to be my C values, which are my final amounts, so 30 with 3.75, and then 1 and 0.10. And then my Y values, for the top, I'm going to have my A column, so 1 and 0.25 with 30 and 3.75. Okay, once I have these, I know that I have a matrix A, B, and C. And I can come over to Desmos and type in new matrix. Once we have our new matrix, I'm going to type in A as my top matrix, so 30, 3.75, 1 and 0.1, and then I'm going to have a new matrix, and that is going to have my 1 with my 0.25, and then 30 with 3.75. And then I'm going to have my C matrix, which will be 1 with 0.25 and 1 with 0.10. And if I want to solve for my number of quarters first, I'm going to type in DET of A divided by DET of C. And this will work for any X value you have. And I know that my screen isn't quite big enough. Let's see if I can shrink this down just a little. So you can see the whole thing. So what we've got here is we have x is equal to 5, so that means that I have 5 quarters. And then the dimes are my y, so I'm doing DET of B divided by DET of C. And that gets me 25 dimes. Okay. So that is your money problem. Our next problem is a current problem, and we're going to set these up exactly the same way every single time, okay? So I'm always going to have the equations x plus y is equal to the miles per hour going with the current. And then I'm always going to have x minus y equals your miles per hour going against the current. Okay, and hopefully this will make sense in just a minute. Okay, so what I have to do is I still have to label what my X and my Y's are. Okay, so I'm going to move that down. I'm going to have X is equal to, so this question says Lance Armstrong is riding 162 miles on flat ground in 6 hours with a good breeze at his back. Okay, so he's going with the current. He's going with the wind. Now this setup is going to work for anything with the wind current. If you're riding in a boat and you're going on the water current, if you're riding in an airplane, so anything that talks about winds, breezes, riding with or against something is going to be a current problem. Okay, it takes him 10 hours to go 90 miles with the same breeze working against him. So this is against. How fast is Lance going on the bike? Okay, so we're looking for, X is always going to be the speed of the bike or the boat or the whatever the object is that's moving. And then Y is always going to be your current speed. So this way, this is our breeze speed or our wind speed. Okay, so when I go to set up my equation, I'm going to have X plus Y is equal to the miles per hour going with the current. So this is 162. To find miles per hour, I divide the number of miles gone in 6 hours. So 162 divided by 6, that gets me 27. So that means that going with the breeze, we went 27 miles in 1 hour, so that's equal to 27. And then I'm going to set this up and have X minus Y is equal to the miles per hour going against the breeze. So he went 90 miles in 10 hours, so that gets me 9 miles per hour. Okay. From here, you can set up your matrices. So we are going to have our bottom matrix, X is equal to, on the bottom, I'm going to have 1, 1, 1, and negative 1. Y is going to be the same. At the top of my matrix, I'm going to have my 27 and 9 listed here. I'm going to have my 1 and negative 1. Again, this whole row should line up for my X's. And then I'm going to do the same over here. The first row should line up, so 1s and 1s with 27 and 9. I now have all the information I need, A, B, and C, to go solve a matrix. So I'm going to clear this all out. I'm going to have a new matrix. My A matrix is 27, 1, 9, and 1. My B matrix is 1 with negative 1, and then 27 and 9. And my C matrix is 1 and 1, 1 and negative 1. To solve for the speed of the bike, I am going to type in DET of A divided by DET of C. Oh, I may have plugged in something a little wrong. Oh, I did. Okay, so be really careful. This is 1 and negative 1. This is 1 and 1. So my speed for X should be 18. Okay, so the bike speed is 18 miles per hour. Now we want to solve for the wind speed. My wind speed is going to be DET of B divided by DET of C, and that gets me 9. So the bike speed, or the wind speed, is 9 miles per hour. This last question is on interest. Okay, so we're going to be calculating how much money is put into some accounts based on the interest earned and the initial total amount. So it says that Jeff invests $4,500 into 2 accounts. The savings account earns 6% interest, while a money market account earns 9% interest. After 1 year, he made $300 in interest, from both accounts. How much did he invest into each account? So there's two accounts, which we're going to put our variables as. So X is equal to the savings account. Y will be equal to our money market. Okay, so we know that initially $4,500 was invested into the two accounts. We don't know how much. We just know that it's a total of $4,500. So we're going to have X plus Y equals $4,500. Okay. The other information I'm given is that we have interest. So on those amounts, $300 is earned in interest. In order to figure out where that interest came from, we have to multiply the interest rates by the savings account and the money market. The savings account has a 6% interest rate. We have to change that to a decimal. You change it to a decimal by dividing by 100 or moving your decimal place 2 places to the left. So that gets me 0.06 times X. Gets me how much money is earned in interest on the savings account, plus 9% as a decimal is 0.09. So plus 0.09 times Y. Once we have those equations set up, we can go ahead and set up our matrices. So I'm going to have X is equal to, Y is equal to. My X denominator is equal to 1.06, 1 and 0.09. And then my Y denominator is the same, so it's 1.06, 1.09. And then from here, we can go ahead and do the numerator, so that's 4,500 with 300 and 1 with 0.09. And then our Y's are going to be 1 with 0.06, and this should be a 6, not a 9, and 4,500 with 300. Okay, and I can come over to Desmos, value of 4,500 with 300, 1 with 0.09. Then I'm going to have 1 with 0.06 and 4,500 with 300. And then my last matrix is going to be 1 with 0.06, 1 with 0.09. And I want to solve for Y, or the amount in my savings account, or in his savings account. And I have dt of A divided by dt of C. That is going to get me a total of $3,500. So there's $3,500 in the savings account. And we're going to solve for Y. Y is going to be my money market account. That's dt of B divided by det of C, which is $1,000. And that is how you solve special systems of equations.